Okay, today we're going to be factoring polynomials, and we're going to be focusing on factoring using greatest common factor in different squares, in case you want to write that into your notes. Let's get started. So first, before we start factoring, let's consider these polynomials, and we're only going to look at the top one. The other two we'll look at in class. So we know how to multiply these already. We know how to multiply a monomial with a binomial. We just distribute that monomial to each of the terms inside of that binomial and use the product rule. So a times 3a is 3a squared, and a times 7 is 7a, right? So what we're doing today is we're going to be given this, 3a squared plus 7a. And we're going to work backwards so that we can change it back to a product. And the first method that we're going to use is greatest common factor. Now we factored in an a originally, right? So now each one of these terms has at least one factor of 1a. Okay, so we could factor out using greatest common factor. If you remember from your middle school days, we could factor out an a. And the way we would do that is we take 1a out. And if we take 1a out of 3a squared, we didn't do anything to the 3, but if we take an a out of a squared, right, take 1a out of 2a's, how many a's do you have left? Just 1a. And if we take an a out of 7a, you take 1a out of 1a, you don't have any a's left. So it's just 3a plus 7. So that's what we're doing today. We're looking for a greatest common factor so that we get back to that original product. And that's what our first half of this video is going to be on. So first, what is factoring? Separating a polynomial back into a product. So if you take a look at this one, 4a squared plus 8a, when we want it in factored form, we want to change it back to a product. We want to change it back to multiplication. We want parentheses, okay? So the way you would do that, and the way we're going to learn today, we're going to use greatest common factor. And the way you would do that is you would first look at your coefficients and see if there's a greatest common factor between your coefficients. Remember, greatest common factor is the biggest number that you can divide two or more other numbers by. All right, so if we look at 4 and 8, the biggest number that we could divide both 4 and 8 by is 4. That would be the greatest common factor. But what you would do next is you would look at the variables and see if there's a variable that you could take out. And I'm going to give you the rules on this in just a moment, but in order to take a variable out, it must be present in all the terms in your polynomial. And this a is present in all the terms in the polynomial, so I can, this was an a squared, I'm sorry, I can take out an a. Now how many a's can I take out? Well, this 8 only has one a, so I can only factor out one a. All right, let me do that back in red. And then we would just divide. All right, 4 divided by 4 is 4. And I'm talking about these two 4's here. And then if we take 1a out of a squared, we only have 1a left. So it's going to be a plus, then 8 divided by 4 is 2. And if we take 1a out of 1a, we are left with just a plus 2. And go ahead and distribute this. If we distribute this, 4a times a plus 2, you multiply 4a times a is 4a squared, and you multiply again 4a times, oh, that's a horrible squared, 4a squared, that's still bad. There you go. If you multiply 4a times 2, you get plus 8a, and you get what we originally started with, okay? So that's how you factor. You just look, or at least using the greatest common factor, that's how you factor. Now, if you happen to find a polynomial that cannot be factored, we always call that a prime. And we'll talk more about primes in just a moment. All right, so here are the steps. A lot of steps. Pause it, write it down. Step 1 is you're going to want to identify the GCF of the polynomial. And to do that, you would first check the coefficients. So look at the coefficients and try to figure out a greatest common factor between the coefficients. All right, that's your first step. Then you want to look at the variables. In order to factor out a variable, the variable must be present in all the terms. If it is present in all the terms, then you're just going to take the one with the smallest exponent. Then you're going to divide each term by the greatest common factor and leave the remaining factors in parentheses. And check your work by distributing, which we did in that last example. So we're only going to do a few of these examples. I'll do number 1 and number 24. And then the rest we'll do in class. So if we look at 3x plus 12, and we want to factor this, what we're first going to do is look at our coefficients. Well, we have 3 and 12. All right. So if we look at 3 and 12, you want to think of the greatest common factor, the biggest number that you can divide both 3 and 12 by. And that's 3. So you can take a 3 out, right? Now, if you take a 3 out, Actually, before I get to that, can we take a variable out? Well, we have an x here, but why can't we take an x out? Because x has to be present in all the terms in order to factor it out. And it's not present in that second term. So the only thing we could take out is a 3. The only thing we could factor out is the 3. Then we divide. What you're going to divide is you're going to divide this first term by what you factored out, which is 3. And 3x divided by 3 is just x. The 3's would turn into a 1 and cancel out. And then you're going to divide this second term by what you factored out, which was 3. And 12 divided by 3 is 4. So that would be your final answer. And I challenge you to distribute this, and you'll see that you end up getting 3x plus 12. Now let's go ahead and do number 24. All right, so first you're going to look at your coefficients, and I'll underline that in blue: 3, 9, and 15. So you're looking for a number that you can divide 3, 9, and 15 by. The biggest number that you can divide 3, 9, and 15 by. And that number would be 3. So you can factor out a 3. Then your next step is to look at the variables, and I'll do that in green. We have an a here, but in order to be able to factor out an a must be present in all of our terms, or in all 3 terms. And in this case, it is. So you might be wondering, well, how many a's can I take out? How many a's can I factor out? How many a's can I divide by? Well, you would figure that out by looking for the a with the lowest exponent, which happens to be that a. So you can only factor one a out. So it would be 3a. All right. Then in green, in red, oh, I did red already. In blue, we have b squared, b to the third, and b to the fourth. So all 3 terms have at least one b. So that means we could take out a b. How many b's can we take out? Well, the b with the smallest exponent would be b squared. So you could take out 2 b's, b squared. And then last but not least, we have c squared, and c to the third. So again, c is present in all 3 terms, so we could take out at least one c. Well, in this case, we could only take out one c because that's the one with the lowest exponent. So we can only take out one c. Let me do that in red. And then you start dividing. So you're going to divide this by this. And the way you do that is you just divide the coefficients. 3 divided by 3 would be 1. Those cancel out. A to the third divided by a. Okay, when you're dividing variables with exponents, all you would do is subtract the powers. So it would be 3 minus 1. Or you could think about it this way. If you have 3 a's and you take 1 away, how many a's do you have left? You have 2 a's left, or a squared. All right. If you have 2 b's and you take 2 b's away, you don't have any b's left. If you have 1 c and you take 1 c away, you don't have any c's left. So that would just be a squared. That's minus. And then you do 9 divided by 3, which would be 3. Divide the coefficients. And then you take 1a out of a squared. Right? How many a's do you have left? You just have 1a left. You take 2 b's out of b to the third, or b cubed. How many b's do you have left? Just 1b. And you take 1c out of c squared, or c to the second power. How many c's do you have left? Just 1c. So it'd be abc. Then that's going to be plus 15 divided by 3, which is 5. You take 1a out of 1a, you don't have any a's left. You take 2 b's out of b to the fourth, you have 2 b's left. And you take 1c out of c to the third, you only have 2 c's left. And I challenge you to pause the video and go ahead and distribute this, and you'll see that we'll end up with that original trinomial. So that's how we would factor using greatest common factor. Now let's go ahead and shift gears, and now we're going to talk about difference of squares. So if we take a look at this, x plus 4 times x minus 4, let's go ahead and distribute this out. It's x times x, which is x squared. And then we have x times negative 4, which is negative 4x. Then we have 4 times x, which is 4x. And we have 4 times negative 4, which is negative 16. These 2 4's in the middle are going to cancel out. Negative 4 plus 4x is 0. So all we're going to be left with is x squared minus 16. And we'll do these other 2 examples in class, but I want you to just notice something here. All right. If we look at the 16 there, what's the square root of 16? The square root of 16 is 4. And those 4's happen to be there. Okay. What's the square root of x squared? The square root of x squared is x. Okay. And we have those x's there. And this is what we call a difference of squares. So if we have a sum, and we have a sum of squares, 2 things that we could take the square root of, then we have what's known as a difference of squares, and we could factor this using a special rule that we're going to talk about in the next slide. So here's a special rule. You can go ahead and pause the video and write all this stuff down. So here's how you would factor a difference of squares. If you have a difference of squares, a squared minus b squared, you could factor it in this manner. All right, so what you could do is you could write a plus b times a minus b, as you saw in that previous example. In the previous example, we had x plus 4 times x minus 4, and that equaled x squared minus 16. But the key term here is difference, so it must be a subtraction. It must be a sum. So difference of squares won't work with sums or addition. It must be subtraction in order for that to work. All right, now let's go ahead and do number 1 and number 20, and the rest we'll do in class. So number 1 is a squared minus 4. We have a difference, so that's good. No greatest common factor that we could take out. So now what we would do is we would just take the square root. The square root of a squared is just a, okay, and the square root of 4 is 2. Now remember, when we're doing difference of squares, a squared minus b squared, what we're going to end up with is a plus b times a minus b. So this is going to be a plus 2 times a minus 2. And I challenge you to pause it and factor that out, and you'll see that you end up with a squared minus 4. That's your answer. All right, let's go ahead and do number 20. All right, I want to change one thing on this. It says m to the 4th, but actually it should be n to the 4th. Because if not, we would have to take a greatest common factor out first. All right, now this is a difference of squares, so you'll just take because we have a subtraction sign here, you just take the square roots. The square root of 64 is 8. The square root of n to the 4th. Now remember, when you're taking the square root of a variable that has an exponent, you just divide that exponent by 2. 4 divided by 2 is 2, so it'd be n squared. And then that's going to be the square root of 9, which is going to be 3, and the square root of m squared is m. Now we just put a plus and a minus. That's all there is to it. That's how you do difference of squares. I just want to look at one more example with you, which is this one right here, 2n squared minus 72. So here we would have to take a GCF out first. So when you're doing this, your first step is always going to be to see if there's a GCF, regardless of what method you're using to factor. Okay, in this case there is a GCF between 2 and 72. You can take a 2 out. You could factor out a 2, and if you factor out a 2, you'd be left with n squared minus 36. Okay, so always look for a GCF first. Now, once we've done that, look what we have inside of our parentheses. We have the difference of squares. So now we could actually factor this out using difference of squares. Okay, square root of n squared is n, and the square root of 36 is 6. Remember, one of them's plus and one of them's minus. And that 2 that you factored out, you'll just bring that down, and that would be your final answer. Again, I challenge you to go ahead and multiply this out, and you'll see that you'll end up with this right here. Now, we're going to do a lot more examples in class. This was just a starter. I wanted you to have some of these in your notes. But the best way to fully understand factoring is by doing a lot of examples. So we'll do a lot more examples in class. Just make sure you have these already, and make sure you already have the steps in your notes. Okay? I will see you tomorrow. Have an awesome day.